All right, so let's continue our discussion on determinism. So in the last video, I talked about a special relativity, gave an overview of the general concepts, and today I will look into the concept of determinism based on a special relativity, because it seems that people usually use special relativity to defend a sort of determinism. We will look into two arguments by Hilary Putnam and Riddick, two philosophers, and we will see how the concepts that I explain in special relativity applies or does not apply to those arguments. All right, so let's go back to our slides. So this was basically the conclusion of the last video. So we said, okay, in special relativity, we say that we talk about time-like events and space-like events. So compared to pre-relativistic space-time, where we have a total ordering of all events, and because of that we have something called time. We do not have that time in special relativity anymore, because we do not have that total ordering. We only have just a partial ordering between some sets of events. And so we said that those events that do have a kind of temporal relation to each other that's fixed, we call those events time-like events, and those events that do not have such a fixed order in time, we call them space-like events. So we start defining the light cone. So that's the main idea in special relativity. So the light cone is the cone generated by trajectory of light in space-time from a specific event A. So the yellow lines are called the light cone. So the time-like events would be the events that fall inside this cone. So the blue side and the red side are the time-like events. So we have the future, that's the upper blue part, like the E and B are in future of A. We have the lower red subset of the cone, for example, D is in the past, and we have the present A. And the space-like events are those events that are not time-like. So, for example, C is in a space-like relation to A. So, so the first thing that we need to talk about is basically the concept of determined. We usually use that concept. What is it exactly that we want to talk about here? So, when we talk about determinism, when people think about determinism, what they basically mean is that everything is settled. So if you remember the metaphysical determinism concept, so metaphysical determinism is basically everything is already determined, in a sense that everything is settled, everything is definite, it's real, it has become. So there's nothing to change. We cannot alter anything in the universe. That's the metaphysical determinism concept. So we want to think about this concept determined. We're trying to understand exactly what this means. And it makes sense to think about it, since we're talking in relativity and we want to be as general as possible. We want to make sure that we don't really constrain the concept to a specific form. We should think of definiteness or realness as a kind of relation. So something is definite as of something else. All right, so we're going to think about it in a sense of this kind of relation. That if something is settled, then as of that thing, there are other things that are settled as well. So given that this thing is settled, there are other things that are settled as well. So if it's a relation, then what kind of relation is it? So, the different properties of the relations that we can think of. The most obvious one is that this relation is a reflexive relation, in the sense that any event is definite as of itself, in a sense that if A is definite, if you're at A, then A is definite as of A. So with respect to A, if A is definite, then A is definite. That's trivial, right? So the relation of this definiteness or determined should be something reflexive. But it's also something transitive, in a sense that if B is definite as of A and C is definite as of B, then C is definite as of A. So remember, like it's like saying that if something is real to me now, if something is settled, with respect to me. So for me, something is settled. And I am settled for you. So what I am and everything about me is settled from your perspective. Then whatever it is that is settled for me, it will be settled for you as well. Whatever is definite for me, it will be definite for you as well. So if for me it is definite that, for example, there was a rain yesterday, if that's definite for me, and I am definite for you, then the fact that it rained should be definite also settled for you. So these are the assumptions that we make. These are things that make sense if we understand what we mean by the concept of being settled or being real or have become. And the last assumption is that if, of course, the relation alone is not enough, because there's always a relation between two, we need a starting point. What is the most settled, definite, real, determined thing? What is this one thing that everyone can agree on that it's definitely settled? We cannot argue about. And that's here and now, the present moment. So for each person, again, because we want to be general, we don't want to talk about like pre-relativistic thing. Everything is limited to these events. So at each event, at each observer that we have right now, whatever is going on right now is settled. It's definite. Because that's something that we cannot doubt about. Whatever is going on right now, it is settled. It is going on right now. There's no doubt about that. So that would be our starting point. So A, here and now, is definite and settled. So that's our first assumption, and then we want to use that relations. We want to kind of find a relation so we can extend that kind of definiteness to other areas as well. Now notice that this here and now basically is a present set, right? So the set of all events with respect to the observer A can be partitioned into these different sets. So we have the time-like future, we have the time-like past, we have the moment, the only event, the sole event A as a present, and then we have the space-like events. So these are the assumptions that I'm making here, and the assumptions are basically, they're not very controversial, and we're trying to see what that relation R will look like. By the way, if you want a reference on this, Howard Stein, I will give you a reference at the end. You can read his papers on this concept, on special relativity. All right, so we're going to look into this relation. So the question is, if you're at A, so imagine that we are at A, which classes or events are settled? So as we said, so we have these different classes of events. We have the present class, that's only the event A. We have the time-like events, which is the past. We have the space-like events, and we also have the time-like of the future. Of course, as we said, by our assumption, the present class is obviously settled. That's definite. Whatever is going on right now, it is going on right now. It's definite, it's determined, is over. It's real. That's usually the word that Putnam and also Reid use in their paper. They call it real. It's real. It's here. It's not unsettled. It's not a proposition right now has a truth value. For example, I'm recording this video right now. This is true. You're listening to this. It has a truth value. It's settled. There's nothing contingent about it. It's happening right now. Now, what else? So, okay, this is clear for our assumption that we say A. But what about the past, for instance? Can we say anything about the past? Well, of course, in this kind of most general format, is difficult to say anything about it. I mean, of course, we do have a kind of intuition that past is settled because it has already become. I mean, it's over. But again, because we're working in kind of relativistic format, we have to be clear on this. So we have to make sure that we're not making kind of pre-relativistic thinking here. What we can use, however, to understand this sort of relation, we can actually use the relation of causality, in a sense that the events in the past, based on the way that we define past, based on the light cone, are the events that can have an impact on the present moment. So among all of these events that we have in a space log, only D and B, or any other events in the red part of the cone, can have a causal effect on me, right? That's from relativity, because the influence can only travel at the speed of light, and there are only the events in my past that can reach me in less than the speed of light. So the past events are those events that can have an influence on me. And this is a very good reason to say that as of the present moment, all the events in the past must also be real or settled. Why? Because whatever happening right now is the result of everything that happened in the past. Correct? So look, I'm not claiming any kind of determinism here. We're just saying that there is an effect coming from the past. No one can deny that. The past affects the present moment. Even though you might have like a free will decision in the past, doesn't matter. You did something in the past, and the effect of that free decision that you had in the past reaches now and changes what's going on right now. So all the events that happen in the past, they can have an impact on the present moment. So if for example, I have a cloth and that cloth is wet by a rain from an hour ago, if the present moment I have that raindrop in my cloth, then that means that if this is real, if this is settled, that there is a raindrop, then that rain is also real. That's a real thing that happened an hour ago. If there was no rain, if that was not settled, then I wouldn't have had this raindrop on me. So in that sense, we can see that when the past is affecting the present moment, as of this present moment, we have to make sure that the past is settled. Otherwise, we can get into weird stuff, because any of those events in practice, or at least not in practice, in theory, they could have had some sort of effect on the present moment. And that doesn't make sense to say that their effect is real, but that thing that's creating that effect is not real, is not settled, or has not become. So basically, we're using the relation of causality, and also right now, as we explained in this light cone, the relation of the past as a way to get into this relation of definiteness, which is a good thing, because it makes sense, because if you remember, we said that the relation that we want to have is a relation that should be transitive. And up to now, we're good, because everything that we're talking about right now, so we're talking about relation in a sense that as of A is settled, and as of A, the past is settled. Now, these are all satisfied. They will all satisfy those requirements that we want. For example, A is satisfied as of A, right? That's settled by assumption, so that's the reflexive part. But the interesting part is that the past cone is a transitive relation. So if D is in the past cone of A, and B is in the past cone of D, as we can see here, then B is in the past cone of A. So if D is in the past cone of A, D is definite as of A, B is in the past cone of D, so B is, since we're taking past to be definite, B is definite as of D, therefore B is definite as of A, but that makes sense again because B is in the past cone of A. So that makes sense. So we have a very nice consistent system up to now, and we have the relation. But we still have 2 more classes to go. What about them? Do we have any, can we say that they're settled? Can we say that space-like events are settled as of A? Is F and C settled as of A? Note that the causal relation cannot work anymore, because there cannot be any causal influence between F and A or C and A. As you can see, they're light cone. The light cone can never have A. So it seems that there is no causal relation. We have no reason to say that they're settled. Basically, we cannot claim anything on the space-like. So we cannot really claim that they are settled. So we have to leave them open. But if we leave this space-like open, then we cannot also say something about the future. Then we also have to leave future unsettled and open. And again, we are looking for some reason to make sure that they're settled. For the present and the past, we have good reasons. For a space-like, for the future, we have no reason. And why is it that the future cannot be settled? Because any point in the future will be in the future cone of an event that is in a space-like relation to A. So for example, if you look at E, if you say that F is not settled with respect to A, then E also cannot be settled. Why? Because there are some causal influences from F that can reach E. But since now A can have some causal influence on E, but F can also have some causal influence on E. But if F is not settled as a space-like event, then there is an effect that is not settled. So if that effect is not settled, then we don't know about E. E is also not settled if E is influenced by F. Or another way to say this is, let's suppose that one of these 3 or 4 are settled. Let's say that the space-like events are settled. If we suppose that, let's suppose that that's true. We don't have any reason to do that, but let's suppose that it's settled. If the space-like events are settled, then the future is also settled. Because if F is settled as of A, if C is settled as of A, right, then E is also settled as of C. Because for any points that we choose, for any present moment and any future event, we can always find an event that is in a space-like event with respect to both of them. We can always have them in special relativity. So for example, in this case that I'm showing between A and E, so E is in the future A, C is the common space-like event of E and A. And since the definite relation is transitive, if the space-like events are definite, so C is definite as of A, E is definite as of C, so E is definite as of A. So the future basically is also definite. If you go the other way around, if you suppose that the future is settled, then the space-like events will also be settled, because any space-like event that we choose will be in the future of a past event. For example, F is in the future of D, or C is in the future of B. So if B as a past is definite as of A, and C is definite as of B because it's in the future, then C is definite as of A, which is in the space-like. So we see that if there are 2 possible ways that we can cut the whole space-time. There are 2 possible options. There are no other options. Either the whole space is determined, that's the metaphysical determinism, or only the present and the past. These are the only 2 consistent options based on those 4 assumptions that we have. But the problem is that we only have reasons for the present and the past because of the causal relations that we can suppose, because of the interactions that these events can have on each other. If you have 2 events that can have no interaction whatsoever, we have no reason to say that there is a definiteness relation between them. And that's why we only select the second option. So the space-like events and future are not settled or definite. They're open. It's only the present and the past, only the blue A and the red part of the cone. These are the only parts, the only class of events that are settled. So that's it. That's for the when we apply the special relativity to the concept of definiteness based on those non-controversial assumptions that we have. So it seems that special relativity actually opens up the space of events much more than pre-relativistic spacetime, because in pre-relativistic spacetime we do not have space-like events. And if we don't have space-like events, then it's difficult also to justify why the future is not open. But there we had this idea that even in that kind of pre-relativistic form, we would have those problems with the prediction and all those sort of problems that I explained in the first episode on determinism. But when we come to the actual, to a better model of the world that we're living in, the special relativity, we see that actually the things are much easier for the indeterminists, because now we have actually no reason to suppose that the future or the space-like events are settled. So it seems that the special relativity is actually in favor of indeterminism. But why is it that people think that special relativity is actually argument for determinism? For example, Hilary Putnam has a paper called Time and Physical Geometry they can read. And this is part of the argument that he gives. And we want to see, okay, how is it that it seems that special relativity should go for indeterminism. How do they get determinism out of it? So Putnam says that we now discover something really remarkable. I'm just quoting part of it. Namely, on every natural choice of the relation R. So Putnam also talks about this relation R and being real. So it's the same common language that people use. It turns out that the future things or events are already real. So he explains why that is. Hence, everything that stands in the relation R to you, everything that is simultaneous to you now in your coordinate system is also real. I will go through the argument and then we will see what the problem is. But it is well known that as a consequence of a special relativity, there are events which lie in the future according to my coordinate system, and which lie in the present of you now according to your coordinate system. Since these things stand in the relation R to you now, and you now are real, and it was assumed that all and only the things that stand in the relation R to me now are real, the principle 3, which is a principle of there is no privileged observer in the physical universe for relativity, requires that I call these future things and events real. So it's in the text form, but what the argument basically says, I summarize the argument like this. So the argument says this. It says assume that you and I are in the same place moving at different speeds. If you read the whole paper, he explains exactly what's going on. So imagine that you're walking and you're at the same place. One is A and the other one is B. And we're moving in different speeds. Now, the argument says, okay, assume that's happening. Now, I have A and B in the space-like. And so the blue line are, for example, let's say, I guess is you now. So blue is basically, okay, it's complicated because now I'm reading from Putnam's perspective. So my is Putnam, you is me. All right. So the blue one is Putnam standing alone, and I'm walking. So because of that, we have the basically the distortions of the relativity, and the way that we can actually show that by twisting and these two axes together, so closer together. So the time axis, the space axis, from Putnam's perspective, my axis will become like that, the two black lines that I have there. And so that will happen, right, based on relativity. And then Putnam says, okay, now you now and my now is real. So he says, okay, whatever it is right now is real. That's also we had the assumption that we had. Now these are the crucial events. So Putnam says, imagine that there is an event D in this space-like. Now, since I'm moving, based on relativity, the D events can become simultaneous with B, which is me, and my moving. So D is simultaneous with me, because this is the time axis, so these are all simultaneous at t equals 0. But D, Putnam says, event D is in you now, so that's 3. So D is simultaneous with me, but in my future. So Putnam says that D is in the future of A. And then event D is real to you because it's in you now, or in my now. And you are real to me because A and B are simultaneous to each other. So what's happening right now, as we said, here and now is real. So Putnam says, okay, look, D is simultaneous with you. So it's in you now. And you now is real. You are simultaneous with me and you are real to me. Therefore, D is real to me. But D is in my future. Therefore, D, which is in my future, is real to me. And that's the what did he call? Something remarkable. That's the remarkable conclusion that Putnam gives. But after all the explanations that I did, it's clear the problem of the argument. The argument is this, the problem is this assumption, that event D is in you now, and by you now, Putnam means the present moment, because that's what he supposes in assumption 2, that it's real. It's the present moment is real. So the problem is that Putnam says that event D is in the present moment for me. But that's false, because the present moment for me is only event B. An event that is far away from me, simultaneous with me, is not my present. Because the light still takes time to reach me. It's in the space-like. There is no temporal relation between us. So it cannot be in my present. And it also says that the event D is in my future, but as we can see, based on the correct way of organizing future and past, we see that D is not in the future of A. It's not in Putnam's future. D is in a space-like relation to me and is also in a space-like relation to Putnam. It's not in the you now, it's not in the future. So what's exactly the problem? The problem is that when people think about relativity, what they do is, that's the metaphysical mistake that people usually make. Because of this time distortions and change in the coordinate system, they basically move from that kind of coordinate transformation into a kind of metaphysical transformation of the world, in a sense that they take the pre-relativistic time, which was a total ordering, and make that pre-relativistic universal total ordering, make that relative to each observer. So that's why Putnam thinks that the line BD is the now, and everything above it is future, everything below it is the past. But that was the total ordering of the pre-relativistic classical mechanic. In relativity, we changed, that time does not exist because there is no total ordering of events. There's only a partial ordering between time-like events, but there are also space-like events which do not have that total ordering. So the problem is that people take that classical total ordering of time and make it relative, in a sense that as if each observer has its own universal time, but that universal time and that universal present moment just shifts based on the movement. That's not true. Let's see again another argument. This is from Riddijk. So I just put a screenshot of it. And the title is a rigorous proof of determinism based on special relativity. So people really think that special relativity just is a proof for determinism. And that's the way that he wants to prove it. He says, consider initial system x1, O1, T1. So that's the one on the right. With the observer W1, here it is, in O1, again, here. As well as the inertial system x2, O2, T2, right? So this is the one that is moving, so it's tilted, so that we have the x2 transformed and we have t2 transformed on left. Actually, I'm not sure if you see my mouse, but I'm assuming that you see. Observer W2 being in O2. Let me quickly check something. Okay. Yeah, okay, so t2 and x2. And observer W2 being in O2. Now it says consider both W1 and W2 at time T1 equals 0, right? So for T1, so for the observer W1, imagine that O2 or W2 is at that T1 equals 0, so it's simultaneous. Now, X2, O2, T2 moves at a constant velocity in the direction of O1, right? So it says, okay, the X2 is standing and I'm moving towards it. And because of that, there is this kind of transformation that's happening. X2, so that's my basically time, simultaneous time, or my X axis. X2 intersects T1 in P. So there's an event P on T1, which is above O1. Then we find that for W1, Observer W2 in O2, in the drawn position, the event B, is now. Okay, again, the same mistake, right? So because W2 is at T1 equals 0, it is now. As we say, that's false, is not now. The only thing that's now is O1 or W1. That's the only event that is now. O2 is in a space like, it's not now. For W2 in B, however, events B and P occur simultaneously. So it says, okay, look, B is simultaneous with O1, but B for W2 is simultaneous with P because they're happening at the same time with respect to O2. So for W2, event P is present at the same moment T1 equals 0 of W1 that W2 is present for W1. So it says in the same sense that P is present for W2, W2 is present for W1. This now P for W2 is as real as W2 is for W1. Conclusion, P is completely determined at the moment T1 of observer W1. And he also selects an event below P. He says P1 is even past already for W2. So Riddijk again clearly has a classical understanding of time. He has this line x2. He says, okay, everything on that line x2 is real, is present. Everything above it is future. Everything below it is past and determined and real and settled. But that's not correct because the events P and O are in space-like. So they do not have a total ordering. And notice something very interesting, that in the framework that we are talking about in this kind of structure, the realness or settledness of something is not relative, because things that are present to you and things that are in the past or things that are in the future, they do not change. They're not relative. So when something is in your past, it is always in your past. It doesn't matter how you move or what kind of time transformation happens to you. It's always in the past, which is something good, right? Because it basically means that what's real and what's definite is not a relative thing. It's relative to you, of course, because that's the special relativity. Everything is local. But to you, it's always settled. Whatever is in your past, it's always in your past. Whatever is in present is always your present. You cannot change a simultaneous moment, what's simultaneous to you, by changing a time transformation. So that's something solid in the way that we looked at it. But here, everything seems to be loose. I mean, if you're talking about present moments, so everything can change. The present moment can quickly change. That just doesn't make sense. Now, Howard Stein also in a footnote of his papers captures everything that I explained right now. So he says that the failure to recognize this very basic distinction, so he says why is it that people just misunderstand this thing, probably comes from a wrong understanding of the description of temporal concepts as relative to the observer. So in the special relativity, we have this thing that we say, okay, yeah, you have a time transformation and the temporal differences, if you remember the questions that we asked about the temporal difference between two events, and then we said, okay, special relativity for a space-like events, it all depends on the observer. You know, sometimes one of them is positive, sometimes the temporal difference is 0, sometimes the temporal difference is negative. People transfer this thing into a kind of metaphysical notion. Both writers, and that's Riddijk and Putnam, try to make the observer carry with him, as it were, a pre-relativistic temporal structure with his time coordinate playing the role of time. You see, so he says that basically you have that pre-relativistic time and you just carry that with you and just make that relative. So you just make that present moment just universal but relative to yourself. But what Einstein's argument showed was that a certain procedure of measurement singles out, and this is just whatever it does, the only thing that it does, singles out a time axis, that's what it does, and gives numerical time differences dependent upon that distinguished axis. Not that an observer's state of motion imposes upon him a special view of the world structure, you know? The whole structure is not going to change. The time structure does not change. The only thing that changes is that When you have an observer, you have a just specific numerical time difference that you can measure. That's all, based on your time axis. That doesn't mean that there is a metaphysical structure that is keep changing based on my motion. This illegitimate metaphysical interpretation of the time coordinate appears perhaps most plainly in Riddich's phrase describing C and A when at rest with respect to one another as experiencing the same present. There is, of course, no such experience. We do not, the only thing that we experience right now is whatever happening here. There's no now and there. There's only here and now. The fact that there is no experience of the presentness of remote events was one of Einstein's basic starting points. That's how Einstein started everything. He tried to capture this concept of presentness, but then Einstein realized that everything depends. There's this kind of locality to it. And we cannot really talk about things that we don't experience. So he sets up these lights and then clocks, lights going back and forth, and tries to find a concept of simultaneity based on those signals that he receives. Okay, so yeah, basically that's it. We saw that. So in the first video, we talked about scientific determinism. That's the prediction from within. We said, okay, that's false. And then we said, okay, prediction from without. But we asked for some arguments. And it seems that people usually use special relativity to come up with an argument for prediction from without, in the sense that everything is determined. But we also saw that there is actually no reason to suppose that. And special relativity, if understood properly, actually is in favor of determinism, not in the sense that Riddick thinks that is a rigorous proof of determinism using special relativity. Now, of course, we cannot disprove metaphysical determinism, because always someone can claim, hey, there's a spirit outside the universe and knows everything. And we cannot refute that. We cannot prove that there is no such a thing. But we have no good reason to believe that it is true. And special relativity actually gives us more reason to believe the openness of future. As I said, that we have the very interesting, consistent system of present and past, which doesn't even change. And it also makes sense with our common sense concept that we have, and also with the causal relations that we can understand. So by that, I believe that we build a good case against determinism. So we have the future open, we have the space-like events open, and the only things that are settled, the only propositions that we can actually have, we can say that they have a truth value, are the present, the ones about the present, and the ones about our past in a kind of relativistic concept of past. Everything else is open, is not settled. So that's for determinism. So if we want to have free will, we need to show that determinism is false. So that's what we did here. We showed scientific determinism is false, and we have no good reason to believe that metaphysical determinism is true. Actually, some reasons to believe that it's actually open, the future, based on special relativity. The other objection to free will. Now, I would like to move on to explain exactly how libertarian free will works. But there's another objection which is also very interesting, but it will also help us understand the libertarian sense of free will, and that's the argument from causal closure of physical causal closure. So that's the other objection that I will explain in future videos. And after we also get rid of that objection, then that will create a space, and then we will see how to build a concept of libertarian free will on that. Cheers.